Hello everyone, welcome to my data mining project presentation. My name is Antony George. I have my teammate Jenshan, Chiang with me. We recently completed this data mining course with Professor Bob Lee. It is a wonderful course. We learned a lot about how to mine the data and then get a meaningful pattern from the data. So in the next 10 minutes, we are going to explain about the project we did recently for this course, which is called New York City Traffic Collision Data Mining. So let's see how we executed this project, and then we'll try to explain the process involved in completing this project. Let's move on to this next slide. Okay, here is the background of this project. If you see in the whole world, the traffic and safety, the collision involving injury and fatality is a major concern for everyone. As you all know, it's a really problem to everyone whenever the collision and injury happens. And every year, around 1.35 million people are killed in road accident, and almost 3,700 people are killed globally in road with the crashes involving cars, buses, and motorcycles and bicycles. So we thought this is happening because of the lack of prediction and planning to avoid the collision is one of the major causes for this injury and global loss. So this made us think to do this project, do some data mining against this collision data. We were looking around a lot of data sets in the internet, and then we decided to do New York City collision data mining. So if you look at the purpose and scope of this project, we selected New York City. In New York City, more than 200,000 vehicle collisions occur in 5 boroughs of New York City. So in order to provide safe streets to New Yorkers, New York City Mayor and New York Governor implemented a Vision Zero program to reduce the fatality and injury from traffic collision. So it's already there. The program is already there. It's being run. And the purpose of this project is to run data mining algorithm against this New York City collision data and come up with insights to reduce injury and fatality for Vision Zero program. So we hope we have some answers which we can share to this Vision Zero program to reduce this fatality and injury in New York City roads. And in this project, we applied various machine learning algorithms ranging from J48 decision tree, clustering, association, and to identify the data patterns within the data set. Next slide. Okay, so before we start this project, we came up with this problem statement because every data mining starts with the question, like what question we are trying to answer. So we came up with these 3 questions: what, when, why. So we are very much interested in to understand what area of New York City or intersection is more prone to accident. We are hoping to get results from the data mining for that. And when, what time of day the most of the accident happens, and why. Basically, what is the primary reason or contributing factor for collision, injury, and fatality? Meaning, is that due to driver inattention, or is that due to the bad tires in the car? Is that due to signal not working properly? So we're trying to find answer for that why. And then the third one is obviously we are trying to see any other possible data patterns leading to reduce the fatality rate. So these are all the questions we had in our mind. So with that, we started our data mining process. So let's see how we are going to solve and answer these questions. Next slide. Okay, so here is the sheet which explains the data set which we used. So this is the data set originated from New York Police Department. So whenever the accident happens, the New York Police Cops provides this collision data for every motor vehicle collision since July 2002. So basically, so these records includes the location, coordinates and other metadata, and the number of injuries and fatalities. If you look at down, this is like a 29 field or 29 attribute data set, which includes the crash date, crash time, and which borough the accident happened, zip code, and location, and street, and whether any person is injured, killed, and there are a lot of information from each record. And this data set is around 1.69 million records as of July, which covers the data ranging from 2012 for all boroughs of New York City. So this data we downloaded from the below website, City of New York. The one at the bottom URL, the data.city of New York, that's where we downloaded the data, 1.69 million data. So we have the data set. Now let's see how we are going to proceed with that data set and trying to find an answer from the next following slides. Okay, so this slide is before we jump into this data mining, we want to see how this is basically the graphical representation of this 1.69 million records from 2012 until now, which gives you like a high level overview of number of accidents by borough and injuries and all those things. It doesn't involve any data mining, it's just a graphical report comes out of this 1.69 million record. It doesn't give any insights. It is just a pointer of how many collision and how many injuries across the 5 boroughs. Okay, so let's get on to the next slide and then see how the data mining it's getting done. Okay, so here is a slide. I'm going to explain about this data mining methodology we used in this project. As per this this course, we learned the data mining starts off with the data preparation. So if you look at the top portion of it, we started off with the data preparation where we did a lot of filtering the data and we corrected the missing value, and which took lots and lots of time. I mean, in regular class assignments, we didn't spend that much time, but when it gets to the real data, it's a good amount of work. Like data preparation itself, it's a huge task. We have to do it, and then right after that, we did a data mining and modeling. That's where we applied all the algorithms we learned in this class, and tried to come up with an answer for the questions we have. And then the last is a result analysis based on the modeling result. Based on the model confusion matrix and other thing, we analyze the result and come up with an answer to that question. So I would like to spend a little bit of time on explaining data preparation in this sheet. It's data preparation because the data set which we chose is like 1.69 million records. So it's very, very huge. The wake out or any desktop tool can't handle that much volume of data. So first what we did was we just filtered the database for only 2 boroughs like Manhattan and Brooklyn. I think that's where a majority of the accident is happened. So we chose that to reduce the data set size, and that didn't help. And then the next filter we did was the collision with injury and fatality. I mean, as I mentioned, this 1.69 million records contains the collision data, the collision without injury and collision with injury. So we restricted our data set to the collision with injury and fatality was considered for this. And after that, we got around 25k data points. We were able to reduce our data set from 1.69 million to 25k data points. So even after that, Veka, we are not able to handle in Veka because of this 29 attribute. So we decided to cut down these attributes to needed attributes to answer a question like whatever the attributes needed for when, where, why, only those attributes were selected. For example, the collision ID is not meaningful to answer a question. No collision ID or And also if you look at the location, there are like we have location, latitude, longitude. So there are like repeated information in this one record. So we just chopped off those records and then reduced these attributes to 9 attributes. And then finally, some of the attributes missing value, we filled it with mean mode substitution. And the crash time, we discretized with modified with closest hours, meaning if the accident happens at 4:30, 4:15, so we just put it to 4 o'clock, so that we have all the records is around like 1 p.m., 2 p.m., 3 p.m., 4 p.m. instead of with the minutes. So that helped us to identify what time most of the accident is going to happen. So once the data is done, let me move to the next slide. Once the data preparation is done, we applied the below tree data mining technique, J48 decision tree, which is a classification algorithm, clustering, simple k-means, and association a priori to find this item sets. Hoping any two factors would answer any of our question: why, what, and when. Okay, so that's what about data mining, and I'm going to pass it on to my teammate Jen. He's going to explain the remaining how we applied in Veka and the confusion matrix and all those things. And I'm passing over to Jen. Jen, you can proceed.
Next, I'm introducing what method we use on our analysis to find out the answer from the problems. And we did all the analysis on Weka. And the first question, what location got the most collision occurs in Manhattan and Brooklyn? For this question, we use some k-means clustering to do the analysis. The attribute we used were borrowed. There are two items inside, Manhattan and Brooklyn. Approx crash time, location is GPS information, collision impact, there are three items inside. And the result is over here. We got two clusters, and they both GPS information. So we put it into the Google Map and find out where is it. In Manhattan, we found out the most dangerous intersection is on First Avenue and 97th Street. In Brooklyn, it's Atlantic and Eastern Avenues. And the second, when is the higher chance to encounter injured fatal accidents, and what contribution factor for the accidents in Manhattan and Brooklyn? So we separate it to the fatal accident and the injured accident, and we use the k-means clustering. And the attribute you can see over here, and the result over here, we got the main reason for the collisions were driver inattention, distraction, same as in Manhattan. The time, the 6 p.m. in Brooklyn, got the most collisions. In Manhattan, is 8 p.m. And now let's look at injured accidents. The attribution almost the same, just change the number of person killed to the persons injured. And the results over here. And we can see the reason for the injured collision. There are driver inattention and distraction, same as in fatal accidents. But the time is a little different. In Brooklyn, it got the most collision at 5 p.m. In Manhattan, it's 6 p.m. And what causes collision with injured fatality? And we use a priori association to find out the relationship. And the attribute we use a borrowed contributing factor vehicle 1, vehicle type code 1, collision impact. And let's see the result. And we can see vehicle type code sedan got the most relevant to the collisions. And the second is we can support utility vehicle. And we can see the driver inattentions is most relevant to the collisions. So the result, we can say driver inattention distraction is the reason for the collisions, and the result is same as the K-means, right? And now let's see what time is the most dangerous time. The graph is from the dataset, and we can see the hours and how many collisions happen. So we can see we got a very high accident at midnight, and another high period is 4 p.m. to 7 p.m. He also matched the result from previous the K-means, right? And we'll check that time. We check it by J48 decision tree, and that's the result. And the result, we check the accident, and the driver inattention is the main reason. We got very high collisions number over here, and it's at 5 p.m. So it's matched the graphic we just saw. So the result, we can say for accident driver, the most dangerous time is 5 p.m.
Thank you, Jenshan. Thanks for explaining all the data mining algorithm. So now we have answers for all our questions: why, when, and what. In Manhattan, First Avenue, 97th Street is a dangerous intersection, and Brooklyn, Atlantic, and Eastern Avenue is a dangerous intersection. And then for the when question, we learned around 12 midnight and 4 p.m. to 7 p.m. is a dangerous time. The accident happens with severe injury and fatality. And also we learned the driver inattention is a cause for majority of the accident, and then the vehicle type is sedan. So with that finding, we would like to offer some suggestions to Vision Zero program. As most of the accidents tend to happen because of driver inattention and distraction, so we recommend to educate drivers and display caution boards at dangerous intersections. I believe government is doing it, but we have to do more and then educate the drivers about that. And then the second thing is reduce the speed limit on those dangerous intersections and install speed board display. So that helped them to grab the driver's attention to avoid collision, injury, and fatality. And also we can think of increasing the police patrolling around that area. And also the other thing is we can leverage the technology like a GPS system. Whenever the driver enters the accident-prone zone, we can display a warning saying there is a potential dangerous area ahead. Drive safely or something like that. That would help the driver to say drive safely in those intersections. And then the last point is to reduce fatality and injury. If the injury happens, you have to save that person, quickly save that person. So in order to do that, we suggest to deploy enough number of emergency personnel around high accident prone areas. This will help the people, to take the people to hospital and then give them care quickly. So these are all the suggestions we found from data mining data pattern. So we'd like to have for that to Vision Zero program. Okay, thank you for your time. Thanks for watching our video. Hope you learned something out of it. It is a wonderful experience working with my teammate Jenshan and with Professor Lee. So we had a very, very nice learning. And thank you for your time in watching this. Thank you. Bye.